Hi everyone. In today's video, I am going to show you guys how to use the ABC tables from the Nories and Nautical tables to calculate the compass error. I hope you have watched my previous videos on compass error calculations. If not, they are in the description section below. Please remember that today's video will focus on the use of ABC tables only. So there might be some things I may not explain in detail which I have explained before or previously in my other videos. So let's get started with today's question. So in today's question, we have the date, it's October 5th, and it is approximately 8:31 ship's time. And on the ship, the difference between the GMT and the ship's time is plus 10 hours. The ship is in position 49:32 north, that is 49 degrees 32 minutes north, and 149 degrees 33 minutes east. The celestial body is the sun, that was observed to bear 130.5 degrees compass. Alright, and the chronometer was showing 10 hours 33 minutes 14 seconds, which was 2 minutes 13 seconds fast on GMT. That means you have to solve the ambiguity of the chronometer time. You have to find the deviation of the compass if the variation was 8 degrees west. So naturally, before you find the deviation, you will also have to find the compass error. But today's video, like I said, will focus on showing you how to use the ABC tables. But let's solve the question as we would in the real situation. So if you have been given the chronometer time, you have to solve the ambiguity of the chronometer time. So that means you write down the chronometer time as is given to you in the question, that is 10 hours 33 minutes and 14 seconds. But what you also do is you write down the other option by adding 12 hours to the hour. So we will have 22 hours 33 minutes and 14 seconds. So the chronometer, if it's showing 10:33:14, it could be 10 in the morning or 10 at night, which would make it 2200 hours. Then the error given to us is 2 minutes 13 seconds fast. When it's fast, we always subtract. So I will subtract 2 minutes and 13 seconds from both scenarios. Right? So when I subtract from both the scenarios, what do I get? I get 10:31:01 or 22:31:01. The zone given to me is, of course, we are in the east longitude. The zone given to me is plus 10 hours. It's given to me already. Alright, so if you don't know what zone means, that depends on the longitude in which you are, longitude and the area, geographical area where you are. I won't explain all that because I have explained it in my previous videos. So 10 hours is given as the zone correction. So that means you are 10 hours ahead of GMT based on your longitude and geographic location. So your ship's time is in this case 20 hours 31 minutes 00 seconds, or it could also be 32 hours 31 minutes 01 seconds. So this should be 01 seconds, not 00, sorry. Yeah, but we cannot have anything as 32 hours. So what can we have? We'll subtract it from 24 and we'll make it 08 hours 31 minutes 0 seconds, 01 seconds, right? So that is our ship's time. So there are two options of ship's time. So what I'll do is I'll erase this. I only wrote 32 because I want to show you how to calculate the time. So 8:31. So we have two options of ship's time. Now how do we know which is the correct option of ship's time? We will see the hint which is given to us in the question. So the hint given to us in the question is that it's 5th of October 8:31 in the morning on our ship, right? So immediately what I'll do is I know that this has to be the correct time. So I'll write 5th of October here, 8:31. That means I don't consider this scenario here. Right, so this is what I know. I know that it's 5th of October on my ship at approximately 8:31 ship's time. And using that hint, I decide that this is my correct ship's time. So the first option doesn't work for me. But if it's 8 o'clock in the morning on my ship and I'm 10 hours ahead of GMT, that means at GMT, where it is 22:31:01 at night, this must be 4th of October. Right? Because I'm 10 hours ahead of GMT. So in GMT, it's still 4th of October, night 10 o'clock or 10:31. And on my ship, which is 10 hours ahead of GMT, it's 5th of October, 8 o'clock in the morning already. So what I'll do is I will make sure I write my GMT time separately with the date, because remember the date given to me in the question is 5th of October. That is the date on my ship. But I'll be using the GMT time to calculate my compass error, because that is the time that is used in the nautical almanac. And according to the GMT time, the date is 4th of October, not 5th of October. Alright, so I have written it separately so I don't make any mistakes. Now using this date and time, I will be going into the nautical almanac and finding the details that need to be filled to calculate my compass error. So GHA, increment, all that, I will find that out. Alright, so I will be going one time into the almanac and finding everything out. So make sure you watch carefully on how I get the values. So I'll go into the almanac. As you can see, this is 4th of October. You can see at the top 4th of October 2004, right? And my GMT time is 4th of October 22:31. So this is 4th of October on the extreme left, you can see, right? So let me highlight this. This is 4th of October. And I need to find for 2200 hours, so that would be somewhere here, 2200 hours, right? But remember, I have to find the GHA of the sun. So where is the sun? You can see that if I zoom out, all right, so you can see sun is written here. All right, so make sure when you go into your almanac, you find the correct column of sun, and you can see that the GHA and declination is provided here. This is the GHA column, this is the declination column. So for 4th of October, if I zoom out again, for 4th of October 2200 hours, my GHA is given here. So let me zoom in. My GH is 152.53 minutes and my declination is 4 degrees 44.8 minutes south. Alright, but while I am here, I'll also find out a couple of more things, and that is my GHA is my declination increasing as I go from 2231 to 2300 hours. So 22, this is for 2200 hours. This is for 2300 hours, but I need to find my declination for 2231. So I can see that my declination is increasing as I am going to the next star. Declination is increasing. That is the first thing I have to make note of. So, and the other thing I have to make note of is this value at the bottom, the D value, D of 1 minute. All right. So why do we have to make a note of all this? Let me go back to the almanac. Let me go back to the notes and see. So what I'll be doing is I'll write down the values here. So 152 degrees 53 minutes was the GHA. The declination that I found was 04 degrees 44.8 minutes south. The D value was 1, and because the declination value is increasing from 2231 or 2200 hours to 2300 hours, I will add the correction that I will find. That is why I found the value of declination, whether it was increasing or decreasing going to the next star. Because this declination that I have found is for 2200 hours, I have to apply a correction to find the corrected declination for 2231:01, which is my time. So now let's go back to the almanac and find out the correction. How can I find the correction? So my correction I will find by going into the increments page. So my time is 22:31:01. So I will go into the increments page for 31:01. As you can see here, I'm already here. I have already highlighted what I have to find. So you can see for 31 minutes and 01 minutes, the increment correction is 7 degrees 45.3 minutes. Right? This is the correction. And my D correction that I will apply to my declination, for a D value of 1, the declination correction is 0.5. I'll be adding it because as my declination is increasing, going from 22 to 23. So definitely I will add this correction because my declination at 22:31 will be more than what my declination is at 2200 hours. So using these values, I will go back and I will put these values here as 0.5 minutes. This is for my declination. So this makes it 04 degrees 45.3 minutes south. I will write down my latitude's value also here because I'll be needing it for my tables. Then increment I found was 7 degrees and 45.3 minutes. Increment is always added, so that makes it 38.3160 degrees. Remember, minutes cannot be more than 60, so if you are thinking 53 plus 45 should be 98.3, cannot be more than 60, so we'll subtract and then we'll carry 1 degree and add it to the degrees side. Right? And then longitude is east, so my GHA will be least, so I will be adding the longitude of 149 degrees 33 minutes. If my longitude was west, GHA would have been the best. I would have been subtracting the longitude, but if longitude is east, you will add the longitude to the GHA to find your LHA. Now LHA cannot be more than 360, which in this case is fine. Right? We also have to name our LHA here. We'll name our LHA east here because when LHA is 0 to 180, we name it west. When it is greater than 180 to 360, we name it east. I'll tell you why this we have to name this, because we will be using this later. All right. So let's keep going. So now we are at that section which I have made this video for, because I have made previously, I've made a lot of videos on compass error calculation. So today's video is not on that, mainly for that. Today's video is to find out how to use the ABC tables given in the Nories nautical tables. All right. So for that we have to go into the ABC tables for the Nories nautical tables. So what I have done is I've got the electronic extract here, and I'll show you how to go into the ABC table. So this is what the ABC tables look like. So if you go into the Nories tables, you will find them. This is what they look like. So first we find the value of A from table A. So if you can see here, I will highlight. So what you can see here is at the top, it says table A. So that's the first thing we'll be finding out. Now how do we find that out? Now you have to see that this vertical column here is the latitude. All right, and I'll zoom out now, and you can see the, although it says here as well, horizontal column is R angle. So going this way, we have the LHA values, the R angle values, and going down, we have the latitude values. So the latitude in your question is 49 degrees 32 minutes. And the LHA value, so let me write it here. So my latitude in the question is 49 degrees and 32 minutes. Doesn't matter north or south. And my LHA value is 310 degrees 11.3 minutes. All right. So my LHA value is between 310 degrees going to 311. Right, because it's 310 11.3. And my latitude is 49 degrees 32, which is between 49 and 50. All right, so it's a vertical column. So I have to zoom out a little bit to show you how I can get the values. So the first value I will get for a latitude of 49 degrees. So for 49 degrees, I can say, looking at the LHA values, going from 0.97 to 1, So here you might have to do a little bit of interpolation, but for today's question I'm just assuming that I can do some mental interpolation. So if I'm going from 0.97 to 1 and my LHA value is 31011.3, I will say that my LHA value for 49 degrees is about 0.98. And similarly, I'm just zooming it here, I'm going from 1 to 1.04. So 50 degrees, for 50 degrees my B value will be somewhere around 1.00 or 1.01, let's say. All right, so you might have to do a little bit of interpolation here. So 310 degrees 11.3 minutes and going to 311 degrees, so it could have been between 0.97 and 1 as well. I'm just assuming here that it is 0.98 and 1.01, but I need it for 49 degrees and 32 minutes, which is my latitude. So I will guess that my A value will be somewhere between 1.98 to 1.01, which will be about 0.99. So this is my A value for 49 degrees 32 minutes latitude and LHA 310 degrees 311. Alright, so I can go into the absolute interpolation as well, but that will make the video very long, but you get the idea here. Alright, so if I have to expand on it, if I have to go really deeper into it, then I will say that I have to find the value by using interpolation. So it's something like this. If I go deeper into it, which I don't want to go, I just show you an example here. So let's say you have here 0.97 and 1, right? And for 310 degrees it's 0.97, for 311 degrees it's 1. Now what will it be for 310 degrees 11 minutes? So you can say for an increase of 60 minutes, which is 1 degree, the increase in the A value is by 0.03. So if I just increase it by 11 minutes, what will it be? So you will do 11 by 0.03, right? Something like that. So 1 minus 0.97 is actually 0.03, right? So 11 multiplied by 0.03 divided by 60, which is equal to 0.0055. So you can say that you will add 0.0055 to 0.97. I'm just showing you an example of an interpolation. Now you know why I didn't go very deep into it, because it kind of would have created some kind of confusion here. So you can say it would have been 0.9755. So for 310 degrees 11.3 minutes, this would be the A value for the latitude of 49 degrees, 0.9755, or you can say 0.98. Right, so that's why I took it as 0.98. Right, so if you really want to go into the depths of interpolation and find the accurate value, this is how you do it. So anyhow, I have found out the A value. It is about 0.99 for 49 degrees 32 minutes. Now let's me find the B value. So B value, you find it out the similar way, except that this time if you focus here, you can see in this value, this is double B for B value, and you have to find the R angle. This is the R angle, of course. So going horizontally, you have the LHA, which is again 310 degrees 11.3, and you can carry out the same interpolation, but this time going down vertically down is not latitude, but it is declination, and your declination was 4 degrees 45.3 minutes. So you have to interpolate between 4 and 5 degrees for these values here. So this is 0.09 in both the cases. So you can see, so your declination value will be 4 degrees 45.3 minutes south, right? And you know the LHA value is the same, but you can see here LHA is 0.09 for both 310 and 311. So you can say for 4 degrees the B value is 0.09. For 5 degrees you can see it's 0.11 and 0.12. So it's almost very close to 5 degrees. I'll say it's 0.12. So for 4 degrees 45.3, which will be between here 4 degrees and 45.3 minutes north, which is the declination, I will say my B value will be somewhere close to 0.11. So between 0.09 and 0.12 it will be 0.11. Right, so this is how you use the ABC tables to find the value of A and B. So when we go back here, what we have to do is basically write here 0.99 and 0.11. But there's something I did not show you, so I'll go back here and I'll show you how to name your A and B. So you can see here B, it says always named same as declination. B is named same as declination. So in this case your declination is south, you will name B south. Right, and let me show you how to name A. So what does this say about A? So A is, you can say, what does A say? Named opposite to latitude except when LHA is between 90 and 270. So if your LHA is between 90 and 270, you will name it same as latitude. Otherwise you will name it always opposite to latitude. So the LHA in my question is 310, which is not between 90 and 270. So I will name it opposite to latitude. So my latitude in this case was north, so I will name it south. And B is named same as declination, so I will name it south as well because declination is south. My latitude is north, so I have named it opposite to latitude. And then the rule here is, if they are same names, to find C, you will add. If they are different names, you would have subtracted. So to find C, I will add A plus B, which will give me 1.10. And because both are south, I will name C south. And then we just simply use the formula tan azimuth equals 1 divided by C times cos of latitude, which in this case would be 1 divided by 1.10 times cos of latitude, which is 49 degrees 32 minutes, which would be giving me an answer of 0.71391, which gives me an azimuth of, so if I go into it, so 1 divided by 0.71391 will give me 1.400736. This is tan azimuth, and then tan inverse in the calculator, press tan inverse and of this value here. So this would be, azimuth will be tan inverse of 1.400736. So that will give you azimuth of 54.5 degrees. Right, but you have to name your azimuth now to find your true bearing. So how do you name it? So you take the name of C, which is south, and you take the name of LHA. That's why we named our LHA. So I will name it south 54.5 east. Got it? Name of C and name of LHA. Now what is south 54.5 east? Now south is 180 degrees and east is 090 degrees. This is north, this is west. So south for 54.5 means you are going 54.5 degrees from south towards east. So to find this bearing, I will do 180 minus 54.5, which is equal to 125.5 degrees. True. This is my true bearing. So I will write my true bearing as 125.5 degrees true. The compass bearing is given to me in the question as 130.5 degrees compass. So I will write that 130.5 degrees compass. Compass is more than true, so my error will be west. Compass best, error west, and my error will be 5 degree, 5.0 degrees west. Right, it's 5 degrees west. 125.5 minus 130, sorry, just write it properly. Right, and the variation is 8 degrees west. Deviation and variation together make up for the compass error. Now because my variation is already more than the compass error, I will subtract it, and this will be 3 degrees east. Right, we can do a cross check. Look at the variation, 8 degrees west, deviation is 3 degrees east. West and east minus should give you compass error, which is 5 degrees west. Now I've explained all this in my previous videos. I don't want to explain how to calculate your uh, deviation from compass error and variation. Please watch my videos which are there in the description link below, or you will also get a playlist at the end of this video. You can click on that. Today's video was mainly to show you how to use the ABC tables, because we normally use a calculator to find our ABC values these days. We have the scientific calculator and we use the formula to calculate ABC. But in the olden days, or still, if you have the Nories nautical tables and you have it on the ship, you can use it to find the values of A and B, and from that you can find the value of C as well. Alright, so you can see here, if I go back to the tables here, you can see the A and B values are given for all the angles, all the values that you can possibly imagine or you can possibly get on your ship, but the system remains the same. A tables are for latitude against LHA and B tables are for declination against LHA. So guys, let me know what you thought about this video and whether you like to use the ABC tables or you like to use the scientific calculator, which one you think is easier. I don't have a problem with either or. Of course, scientific calculator is faster, especially during the exam when you have less time. But try to use these tables when you have time and when you're practicing the questions. It's good to know all these. Alright, thank you for watching and I'll see you soon with my next video. Bye for now.